Hello, welcome to Team 18's OsMowSis application. I will be presenting today on our VM that we have provided to the client. When the client opens the VM, the README file is available for their use. This file includes information on how to access the GUI, what a valid scenario file consists of, some information on the user interface, as well as some advanced usage and troubleshooting information. As the client requested in the new requirements were either a application-based GUI or a web-based GUI, we have decided to go with a web-based GUI using Vue.js as the front end and a Java backend, which is accessed via REST API. So when the client accesses the GUI at localhost 8080 in the web browser, they are given the option to upload a scenario file of their choice. The user can click on this bar, and if for whatever reason the user selects an invalid file or invalid format, they are presented with an error to upload a valid file. So we will now upload a valid file, and once the file is selected and loaded, the lawn is instantiated. As the lawn is instantiated, each mower is displayed facing its current direction along with its energy level. There is a log of what object will execute the next action, as well as displays the last action, current turn, what the go for turn period is, and if the simulation is over or not. The user can determine the total size of the lawn, the number of squares cut so far, and number of squares remaining from the representation of the lawn. And again, number of turns is summarized here. Within the GUI, a next button, a fast forward button, and an end button are supplied to control the pace of the simulation. Once the simulation has finished or it has been stopped, the summary report will display. At any time, the user has the option to upload a new file to test a different simulation. The GUI is extremely user-friendly. As noted before, if an incorrect file is loaded, it will not be accepted, and the user is prompted to enter a new file. While running the simulation, the user only has the following options, so the probability of making an error is quite low. So we will begin to run through the following simulation. Again, after the simulation is instantiated, the user may notice several new features that have been implemented according to the client's requirements. The gophers is one of those features, and as the simulation proceeds, the gophers will actively seek out the mowers. The mower algorithm has also been optimized to avoid the gophers, as well as mowers have been given the ability to communicate with each other to optimize the cutting of the lawn. And finally, the mowers have been given the ability to linearly scan the lawn to better their decision making as well, which we will see while running through the simulation. So as the user clicks the next button, the mowers will begin to take their turns, and the user can see what action was performed. So mower M0, which is located here, performed an L scan, and it is indicated that the energy level is decreased. Within our algorithm, the mowers first all begin taking L scans, so we will cycle through all of those. Now we see that the mower has moved. The recharging pad is still represented by a green square with a battery, and the mower has expended the energy to move. All mowers take their next actions, and we see that it is now a gopher turn period, and the gophers make their moves towards mowers. So the mowers continue to move throughout the lawns, cutting the grass, as the gophers continue to seek the mowers. If a mower finds a recharging pad, its energy level will be restored. If a mower lands on the same square as a gopher, that mower will be removed. And if a mower lands on the same square as another mower, it will be removed. So we can see that the gopher removed the following mower, and that this gopher removed that mower as well. We can fast forward to the end of the simulation, which shows the summary report of the total lawn area, the initial square count, the total grass count, and the total turns taken. You can also view a simulation log, which logs every turn of the simulation for the user's information. And we have the back option. So we have the option here to go back to the simulation or upload a new file. We can upload a new file for a random situation. Again, this loads and instantiates the log. We see here, mowers take random actions and energy is expended. And the simulation moves on. We can end the simulation, which stops and gives a summary report, as well as all the turns that were taken. Go back to simulation to see the final state. And again, we can go back and load a new file. I hope you enjoyed our demo. This has been a fun project to implement, and I hope the clients are as thrilled as we are about the implementation.